We are going to see the fluid dynamics of the physics paper 1, unit 1. Here in the last lecture we've seen about the dimension of this particularly viscosity. Then today we are going to see that what is the streamline flow and the turbulent flow. Here I am going to discuss the highlighted points of this particular topic. When the flow is steady is called as a streamline. That you have to remember, it may come for the MCQ purpose. Okay, the velocity is proportional to distance of the layer from the some fixed layer. Okay, the flow is streamline only as long as the velocity of the liquid does not particular exceed a particular value called the critical velocity. That may come for the MCQ. The velocity is greater than the critical value, the flow is no longer the streamline. Okay, that may come for the MCQs. Then the flow of water during the floods, flow of air during the storms, flow of water in fast flowing rivers, etc. are the example of the turbulent flow. Then the disordered flow is called as the turbulent flow. In case of the turbulent flow, the velocity of the fluid at any point does not remain constant but goes on changing in the random manner, both in magnitude and the direction. At some points, the liquid may have rotational motion, giving rise to eddies or whirlpools in the motion. Then Osborne Rayon experimentally show that the critical velocity of the fluid flowing through horizontal capillary is directly proportional to the viscosity and inversely proportional to the density of the liquid and the radius of the capillary by the equation Vc is equal to k eta divided by density into r, rho into r. Then Reynolds number k plays an important role in determining the nature of the flow. Nature of the flow is determined by this may come for the MCQs. If the value of the K lies between 0 to 2000, the flow of the fluid is laminar flow. If the value of this is above this 2000 and 3000, the fluid is unstable. Flow of the fluid is unstable and it can be convected from laminar to turbulent. Okay. K is greater than this particular 3000, the flow of fluid is definitely turbulent. Equation of the continuity. Here you can see the equation of the continuity is there. The product of area of cross section and the speed remains the same at all the points of the flow in tube is called as the equation of the continuity. This is A1 V1 is equal to A2 A2 is equal to constant is called as the equation of the continuity. Bernoulli's equation, just highlighting the point requires for the MCQs. See here you can see pressure energy per unit mass plus kinetic energy per unit mass plus potential energy. Okay, pressure energy per unit mass plus kinetic energy per unit mass plus potential energy per unit mass is equal to constant is called as the Bernoulli's equation. P by rho plus 1 upon v square plus gh is equal to constant is called as the Bernoulli's equation. This equation you have to remember. Bernoulli's equation states that the total energy of the small amount of liquid flowing from one point to another without any friction remains constant throughout the displacement. That you have to remember. This may come for the MCQ. P by rho into G is called as the pressure head, V square by 2G is called as the velocity head, and H is the gravitational head. Therefore, the Bernoulli's equation is, you can say in another way as, in streamline motion of the liquid, the sum of the pressure head and the velocity head and the gravitational head is constant at all points is called as the Bernoulli's equation. Applications of the Bernoulli's equation: lift up an airplane, aspirator pump, change of the plane of the motion of a spinning ball, venturi tubes. This is called as the applications of the Bernoulli's theorem. Then the Poiseuille's equation for the streamlined and fluid flow. We are not going in detail of this equation, just we are highlighting. Eta is equal to pi pa raised to 4 8 lq is called as the Poiseuille's formula for the rate of flow of liquid through a capillary tube and valid only for the streamlined flow. Assumption: the flow is steady and streamlined. The liquid is in contact with the sides of the tube is at rest. The pressure is constant over every cross section of the tube. That is, there is no radial flow. The tube is horizontal. This is about the fluid dynamics. Here the numericals are there. See dimension of the viscosity that we have seen. Lift of an airplane based on the Bernoulli's principle. Okay, then the product of the area of cross section of and the speed of the fluid remains same at all the points in the flow in a tube. This is called as the equation of the continuity. Okay, such types of the MCQ will be there in the exam. Here the unit 1 of the paper 1 has been finished. Please go through this part. If you are not getting, we can see again. Okay, highlighted things, I highlighted the required part for the exam. Okay, thank you.